Welcome everyone, and thank you for joining us to learn more about microservices and how it can allow you to react more quickly to your business needs. The third annual R2i Evolution Summit would have been held yesterday, and thank you for joining today and taking the time out of your busy schedules. In replacement of our summit, we've been doing several webinars, and thank you for joining this one. And please pay attention at the end of the presentation. We'll discuss about the other ones that are coming up. Opticca is part of the R2i team, and we're working very closely with them. We selected them as one of the partners to work with because of their extensive experience in delivering and projects related to not only the integration of disparate systems, but more importantly, related to the emerging technologies around open source and container platforms. They are a leading partner in this sector. Not only does Google and Red Hat recommend their services, they leverage them themselves. Today, I'll start off by telling you a little bit about R2i for those that don't know who we are. I'll be speaking on that part. After that, Samir Saad from Opticca will be talking about the application modernization and the microservices. And I'll be finishing up with some closing words and the upcoming events that will be following on. Myself, I'm VP of Innovation, and I've been with R2i since the beginning, which is 6 years now. Previous to that, I was with IBM for 29 years, working in technical pre-sales. Samir Saad is a principal consultant at Opticca. He is a DevOps evangelist with more than 12 years experience in helping organizations not only architect, design, but deliver applications at enterprise levels. He's passionate about application architecture, integration, service-oriented architecture, microservices, automation, and DevOps. As a quick summary of who R2i is, the R stands for resources. We are primarily about offering resources, whether it's directly with our large team that both has depth and breadth, but partners like Opticca. For the 2 I's stand for infrastructure, because we sell infrastructure either on-prem or for integration, which is about integrating into the cloud offering that we have. We're going to talk about our solutions. As I mentioned, all of the equipment that we sell to customers on-prem, we virtually use ourselves in our cloud that we install and support ourselves. And we have a very, very large partner network. Opticca is part of that. So on the hardware side, we are really specialists, deep specialists in IBM equipment, Lenovo equipment, and the storage for your organization. On the software side, we're Red Hat partners. We sell the operating systems, backup solutions, security solutions, and are quite involved in artificial intelligence as well. We have a lot of services, whether that be our 24/7 network operating center, managed services, and as I mentioned before, architecting, sizing, workshop proof of concepts, and sometimes we do replacement for technical people at accounts as well. We also have quite a bit of experience working with partners and helping with funding, working with the superclusters such as Scale AI or Engine. So we're very proud of the expertise that we've earned in our 6 years of being in business. We're their very first platinum partner in Quebec and the third in Canada. In last year, we got the North American Partner of the Year for IBM Power Servers. We are the only partner that was selected to be an AI Pursuit partner in Canada, and we have several certifications related to security, which very few actually have for our cloud environment. So we're Lenovo, NVIDIA also, Red Hat, and an IBM Platinum partner. We've recently had awards and are among the top startups in Canada, and we're very proud of where we've gotten in a quick period of time. A quick little commercial on AI, what we've done. We are really one of the first ones out of the gate on AI. I've been working hard in this area for several years, working with customers such as Mila and several universities. We have GPUs in our cloud as well, so if you want to start any projects in AI, please reach out to us. We've got quite a experience in this area. And now I'd like to pass it over to Samir, who's going to talk from Opticca, who's going to talk about application modernization and microservices.
Okay, good morning, everyone. Just 1 second, I need to switch my screen. Okay, let me know if you see my screen now. Kim, do you see my screen now?
Yes, I see it.
Okay, that's good. So, hello everybody. We're going to talk today about apps modernization, some good practices around selecting the most fitting approach and architectural goals and technology selection as well. So, the challenges in today's enterprise is that we are operating really many systems. These systems are heterogeneous. Some of them are legacy, others are modern. Some are vendor-provided, commercially licensed apps. Others are tailored apps, either in-house or by third party. So it's really a complex layout to navigate, and there is no one-size-fits-all recipe when it comes to these application modernization. So I'm going to try to go through some of the ideas on how to find a fitting or a promising approach to achieve good results. So on the x-axis here, we're just going to put this agility scale. If you want to do this as one-shot migration or modernization, or if you're going to do it incremental. So the thing is, the more incrementally you do these things and gradually modernize your apps, is really that you are phasing the risk. It's going to be less risky. On the y-axis, these are the architectural changes that you may need to bring. You may want to stay on the safe side. I'm going to bring minimal architectural changes, or maybe no architectural changes, to reduce the effort and the risk. But this means that you may carry on the previous problems of this application if it doesn't scale well, if it doesn't have DR and so on. On the other hand, you may think of, this is a good chance to bring more value to my app, bring more features and modernize. So when you look at that, on this top left side of the screen, you have most of the risk. Because if you're going to do this as one shot, you're going to bring many changes. This is the most risk you may have. The opposite is on the other side. Also, from effort point of view, the more architectural changes you bring to your app, the more effort it is, but it's also promising with more value. And the opposite is on the other side. So this is a matter of balancing the value to risk. I'm going to focus here on the value scale, how to gradually maximize the value while modernizing apps. And let's take some examples that we find in everyday working in the enterprise. So in example one here, imagine that we have a J2E application running on WebLogic inside a virtual machine that's running on-premise within our data center. There may be some cost implication to operate this, cost for the hardware, cost for the license for the WebLogic, cost for the operations of this system. We may have bad scalability for it because even if the application can scale, we have limited hardware in our data center, and maybe we have some DR issues. So these are just common scenarios that we see. So a simple idea is that you may think about rehosting it. We're not going to do any change in the app or the platform where it runs. We're going to move this virtual machine on the cloud. So this is almost zero architectural change. You didn't touch the app, yet you may have slightly better cost because the cloud provider may provide you stable operation that reduces the operation cost of this application. Scalability can enhance a bit because you have theoretically unlimited hardware there, but maybe your application does not scale very well. That's why it's not pretty green. And you may have better DR options, better reliability, and some automation out of the box. So this is just a simple idea, just rehost the application. Some good candidates for that are G2EE applications. Now, let's take the second phase of modernization, that I will move this application into a container instead of a virtual machine, and I will migrate it from WebLogic to JBoss. So basically, I'm going to re-platform the application. A step like that will really give you better cost saving, because on one side, you have saved the license, for example, that you were paying for a tool like WebLogic, and moving from a virtual machine to container. This is usually less costly because you can run multiple containers on the same virtual machine. So the overhead for operating system is now a shared thing to you. So you are also saving on this side. Scalability is better in general for containers. You can run them anywhere on your nodes. And you have better automation because a container by itself is a sort of an automated template to run an application. So this re-platform is an easy pattern. We see it every day, actually, with our clients. There are some easy candidates and good candidates for this approach, like these modern apps of Spring and Node.js and Python and Go. I see people containerizing these things more and more every day. One final step is that now you may think about re-architecting the app. This one big monolithic that I just containerized on JBoss, I can really split it into some microservices, and maybe some of the functionality can run as serverless, which leads to more cost reduction. So actually, once you split it this way, you may achieve the best cost. Of course, if you go serverless, this is a good cost-saving thing. But also, when you think about now splitting the application into more microservices, now instead of having to scale the whole system to satisfy certain loads, they scale based on demand. The one microservice that receives multiple traffic scales by itself. So actually, this is more optimized model, and you have better scalability and better automation. The re-architect pattern, it will fit in many monolithic applications, actually. But we have very common use cases like the ESPs, the legacy ESPs. They are pretty straightforward to start migrating them to microservices, because when they are developed in some integration modules, and mapping them to microservices is easy. Legacy applications are really good candidate because they don't receive much development. So you can think either that I'm going to start strangle functionality, take some functionality of this legacy system, build it as microservices, or maybe you can just extend it as phase one with some integration microservices on top of it, and later start to take the functionality out of the legacy system to these microservices. So these are the most common three approaches I see, and for us it's mostly that we work with either re-platforming or re-architecture. Rehosting is something that your infra engineers in the data center they do these things with no much involvement from developers, while the other two approaches require involvement. The other three things are just to give you the complete picture, is just repurchase. It's a vendor app, like this is your Active Directory and you're gonna repurchase it, or retire. This system is no longer providing enough value and we can rely on other systems, or retain. You don't have another option. So these are the 6 R's that you have for application migration: rehost, re-platform, re-architect, repurchase, retire, and retain. Do you have any questions? Okay, so just remember that approach is the balance between value and risk. This is how you weigh things and you make selection. Now, when it comes to modernizing and thinking about value, you should question yourself about what a good application is. Is my application good enough? It's not. That's why I'm doing some modernization. So what's a good application? How a good application should look like so I can incorporate these ideas into my vision and my architecture for my application to be to the future state of my application. For this, you can sit with your team and listen to the developers and the operations. What do they think of a good application? Developers, for example, may tell you that it's an easier and faster application to develop, something that enhances our productivity and innovation. On the other hand, the ops will tell you that we need something that's also easier and faster to diagnose, with some operationals, visibility, some good analytics on the logs, some metrics. So whenever we have a problem, we can identify it easily, and best case scenario, we can even predict it before it happens with some monitoring and alerting. Developers can tell you that we need something that's faster to release. So maybe some test automation, some delivery automation. For the ops, they will also focus on that it's faster to patch. So when there is a problem, we really need this to be fixed fast with no big downtime. So you will see that you need to listen to all the entities you have and try to balance this. And now you may think about things like where microservices and DevOps can fit in that. So thinking of microservices, I think most of you are now familiar with the concept. It just, you start to decompose your application into smaller pieces of fully independent applications that's splitted maybe by domain of business or whatever approach that fits your need. So instead of having one big application, you split it into smaller ones. Sorry. So the good thing is that once you have a small entity like this microservice here on the right, it means that this is less amount of code, less lines of codes and less files. So for a developer to understand this and start writing a new feature, this is going to be faster, really, than having to go through a huge code base. For testing this, it's easy to write tests. It's easy to do the QA and UAT because the scope of business is smaller, and then the test cases will be smaller as well. So you will have inherently by this architecture some more productivity in testing and in development. And also releasing it should not bring a big risk because ideally you do not require full downtime of a system if you are deploying just one component behind it. And even if this component failed, your microservices should have been designed with bulkheading in mind. The failure of one component should not make the whole ship sink. So this is really a good approach to increase the productivity that the developers mentioned to you, and to minimize the risk as well. So these are the promising side of it. But nothing comes with no cost, actually. The thing is, you will have the cost now being shifted towards the operation, because at the end, from operations point of view, that big monolithic that we have on the right is a single application. These microservices on the left are 6 applications. So if I have to go through the logs at time of problem troubleshooting, I used to go in one file and I find everything. Now I have 6 files, for example. So it's not easy to correlate logs together. So this may make you think about, okay, now I need to have some log aggregation pattern to make the life of the operations more easy. Same if you have any performance issues, because now you are running in a distributed model. These things are speaking to each other over network. So maybe one service is causing a big delay in the whole system due to something in the code base of the service or in the network model you are using. So now you may need to think about distributed tracing pattern, where you have to monitor the performance of each microservice and see if one is causing delay or bottlenecks in the chain of execution. And now, because you are already processing your data over a network and a distributed model, some security concerns may be raised. So your corporate security department may tell you, like, look, in the past, your system were processing all these sensitive data within the same chunk of memory, so we didn't care. But now your information is being passed through the wires, so you have to have end-to-end security and TLS for the whole model. So now this raises another security concern. And also from scalability, you need to plan. If I want to take the full benefit of microservices, I want my application really to be not tightly coupled to any infrastructure. I want them to run everywhere, to scale, and to work together in a cloud fashion. So these are the things that will really require some effort to get to something that's robust and stable and good.
Samir, can I ask a question on that
Yes,
slide?
sure. Yep.
This is Tamara. I understand that Amazon puts in some 20,000 changes a day into their code, which is something that traditionally, in my counts, that's, which are the monolithic architectures, not something they're able to deliver. And as part of their ability to put in that many changes and, based on microservices?
Yeah, actually, yeah, that helps a lot. Thank you for raising this point. So first of all, yeah, when you go to microservices, you will have a shorter life cycle to release an application. But this goes hand in hand with DevOps, because you need automation to achieve this speed and this frequency of releasing. Automation minimizes your risk. So first of all, microservice, it limits the scope of the thing that you are releasing. This is minimizing the risk. Automating it with proper DevOps practice, this minimizes the time because now it's automated, and minimizes the risk because it's nobody will forget a step in releasing. Another key component that Amazon and the big companies, they really do, is that they have lots of test automation incorporated in their pipelines and the application itself. So this minimizes the need to have any manual intervention from people to approve anything. Like, your code has 90% coverage from tests, and they all pass, so it's safe. They also have these ideas about, you may have advanced releasing strategies like canary deployment or blue-green deployments. This minimizes the risk of going to production and makes rollback easy. So it's a combination really of these things, but yeah, microservice, DevOps, test automation, advanced deployment strategies, this will help. Amazon, I think now they are doing more. The last thing I read is that they release almost something new every 11 seconds. So this is really...
Some of the large accounts I work with, I know they have sort of 2 windows a week where they release changes. And one of the major bottlenecks is the availability of the business analysts to do the testing on the code changes.
Mm-hmm. Yeah, that can be the case. Really, yeah, it's many things that the enterprise has to work on, either the testing capacity or the infrastructure or the level of automation or the apps architecture. So it's this area that has to be tackled, and it's really good to reach this maturity where you really can give the developers the flexibility when something is ready, it gets tested, it gets released. They don't have to wait for a corporate-wide window. So before taking looking at the questions in the question panel, this is the last thing I'd like to mention here, because you see that once you move to architecture like microservices, you really need to have some awareness of the entities you are working with. It's always good, regardless of the architecture, to look at the ops side of the things that you are developers. So a developer who has operational awareness is good, and also an operator who has dev awareness, that's good. So you are playing in a complex layout in the enterprise. You have your infra, you have your network, the security, different apps, teams, DevOps, platform, and operations, and so on. It's good to think about all these entities when you are making your vision for the new wave of applications, because maybe you are embarking on that journey that I'm gonna go microservices, but the security team will tell you that now microservices, I need like end-to-end TLS encryption with Virgin X, and now you will be responsible for the ciphers and encryption and certificates between all the nodes where these microservices will run, for example. You need to look at the other apps and other teams around you, because maybe they have some good practices that you can learn from. You need to look at the infra, because maybe their hardware or network model will support or does not support certain things that you are looking for. And look at the platform. So maybe within the enterprise, you have already Kubernetes or OpenShift, which can make your life easier because it can orchestrate and scale and manage the resilience of your microservices containers better than running them as plain containers, and so on. So it's good to be aware of all these entities, good to collaborate early with them, invite them to the table, and make sure that you have the right balance. Because honestly, for these initiatives, sometimes you have an entity with higher influence. Like if the infra people have higher influence, they may, for example, think about like, there is a shell solution for everything, even our pipeline, which is not going to be the point of view when DevOps people will think about pipeline. It's not necessarily going to be a shell. The same for, if you have higher influence from developers, they will need to have control over many things. And this may lead to, less unification, less standards, and so on. So it's good to figure some sort of balance where you collaborate with everybody, but you don't let one entity to really take over and make this whole architecture leaning towards some side.
We have a question, Samir, that's related to your risk table, I guess, and how to do the migration. So it's like, what's your recommendation on a strategy for migrating a 10-year-old ASP.NET 3-tier monolithic application and move it over to the segmented scalable microservices? And how do you minimize the risk in while improving the scalability? So I guess it's, how do you get there? How long does it take? Because you want to maintain the stability along the way of doing the move.
Yeah. So .NET applications, there are a few challenges. First of all, you are tightly coupled, mostly for the old ones, on Windows. So if you want to, like, if containerization is your ultimate goal, so it's either that you need to think of a platform that's Windows friendly when it comes to containers or orchestration, something like Docker Compose. They are Windows friendly. Others are not. Windows containers is relatively new compared to Linux containers. So if containerization is your target goal, this may limit the platform options that support that, or you will need to move at some point to .NET Core, which is gonna run on Linux. But now this is like a big architectural change. You may need of something that's more gradual. So this ASP.NET application can be containerized as is and run on Windows as containers, for example. But the problem is that sometimes the way people architect .NET apps is that they have some dependency on operating system services. Like we develop some components as Windows services, and these things are not good candidates for containerization. So it's really challenging, and I think there is a high probability that this application will be opened, will be re-architected in a way, and there will be some development needed to bring this to container-friendly architecture.
So I guess the answer is it depends on the code that's in the ASP.NET and that it would be best to set up an outside discussion or discovery with you guys to discuss that particular case.
Yeah. So having it 3-layered, that's good, because you have layered in place. This may ease in the splitting it into microservices, but still there will be many technical details. And by experience, I'm telling you, like with Microsoft stack of development, it's usually harder because of this very closeness to the operating system. Because in containers, you really should be somehow not very dependent on the OS. So that's one of them.
That's what allows you to move it to the cloud or bring it on-prem or port where you want. So, thanks.
Yep.
So let us know if we answered the question, or if there's another piece to that, you can respond in the Q&A. Thanks, Samir.
Okay, let me see if somebody's raising their hand. Okay, so now we discussed, like, these are the different people that you need to incorporate in the discussion before setting the vision for the new application. And the goal is to really establish some architectural goals. My vision is to have something that increases the productivity of my team. Increasing the productivity, this may tell you that, okay, so I need to build maybe an archetype. So instead of developing every microservice from scratch as a blank page, I want to start from somewhere where all this technical overhead is already done in that. So we were speaking about metrics, distributed tracing, log aggregation, all these things. Why not to put this as a common module that's either being extended or included or reused to unify and boost the productivity of developers? So not every team or every developer or every microservice have to be concerned with that. Having some risk reduction. So you may need to plan ahead for some test automation, whether the frameworks that the developers will use to write their automated testing, or the tools for QA, for UAT, and how to integrate this with your pipeline. Also, DevOps may come here as a way to boost the productivity of your delivery for these apps and enhance the quality of them as well. Enhance the reliability and the scalability of the application. So this will make you question the infrastructure and the platforms where these apps will run on, to make sure they provide you with good features for the reliability and scalability. But also on your application, you want to make sure that they can scale in a good way. So if they have sessions is replicated. If they have like cron jobs has logs, so they don't run everywhere where the application is scaled. So these application specific things. Also operation visibility, that, for example, you can say that I want to send all the logs now to Elasticsearch with some correlation IDs, so the operators can do some good analytics and visualizations of the logs there, Elasticsearch or Splunk or whatever tool. I need to expose metrics of my applications to Prometheus or Dynatrace or whatever tool, so that you can do some visual monitoring about it, and maybe even alerting to start predicting problems faster. Enhancing the security of the overall solution, like using trusted open source libraries, and maybe having something in your pipeline to validate the security of the components you are using, the open source libraries, the dependencies in your Docker images, and so on. So the goal of that previous exercise is just to reach this point, and then you can take it to some detailed actions to realize that. The first thing is developing archetypes. This is really a very good thing that I recommend. I will tell you, there is no golden ratio or number when you should start having this. But in my team, when we notice that we have something that's redundant within 3 services or 3 applications, for us, this is an alarm. We cannot leave it there. It ideally should go somewhere. And if this number increased to 5, like this code now is redundant into 5, this is a must-do thing. We have to take this to somewhere where it's centrally managed and reused, either as a parent component that we inherit or as an external component that we include in our dependencies. So building the archetypes, it increases the productivity of your team, because now you offload the development team from having to deal with the same problem in repetitive time. You want to have open ID and JWT token security for your APIs, for example. You should not leave, let every developer handle this separately. They can work together, they can build it once, test it, and promote it as a reusable component, and we are done. So for the next microservices to be developed, we don't think about this at all. It just comes out of the box. So it increases the productivity. The second thing, it increases the unification. So if one developer has to work in the service of another developer, it's easy to understand because he's familiar with this archetype and this architecture. If you are onboarding a new guy, that should be easier. And code reviews as well should be easier because the team members are aware of this architecture. One good thing here is also when security is a big concern, building archetypes, hardening the archetypes and make sure it's secured and trusted, this will make it easy to trust and release any application. Because if the archetype, the base of the application is trusted and passed all the security checks, 90% the services that use it will pass the test. Instead of wondering about every service, is it safe? Is it secure? Does it use trusted library and so on? So this is really a good approach to avoid all these things ahead. And it doesn't take really that much time. And in most of the project I was engaged on, it was easy to achieve a robust archetype for our services in whatever language within the first phase of development, which is, the first 1 to 2 months. It was enough good time that you incorporate all these good ideas into a base component that you reuse in the first or 1 or 2 microservices, and after that you keep reusing it and enhancing it. And the same also applies when you build pipelines. Any questions here? I think there is a question.
No, the question seems to be related to the previous speaker. Previous question, sorry.
Okay, so that's fine. This is when it comes to archetypes. The second thing that you better think about early is how you manage your configurations. Because when you have a monolithic application, it has some configurations, like, it connects to the database. You have a connection string, you have credentials, it has this or that list of parameters. And this application runs on dev, runs on non-prod, like staging, runs on prod, so these configuration varies. The thing is, when you divide this application to 10 microservices, your configuration will increase really dramatically to run the application. And it's good to think about coming up with a solution. So here I'm trying to put the different types of configurations. So the second box here is the pipeline code and scripts. This is one of your configuration item. I see many people, they build microservices, they have a Jenkins file or GitLab CI or whatever inside the code repository. This is how the pipeline is triggered, and their pipeline is there. That's fine. But if you have 20 microservices of the same technology, Python, Go, Node.js, or Spring Boot, 95%, this pipeline is redundant. And I assume that you can easily unify it as one single pipeline. The only difference is parameters that you can send from your application, which makes it really a maintainability issue. If you keep your pipeline script into the code repository, ideally, you should externalize these ones and your application just pass the parameters of how I want this pipeline to behave. where I want to deploy, how I want to build. That's it. You just guide the pipeline. The other layer of configuration here is the build and deployment configuration. So if you move with containers, the out-of-the-box way of thinking, let's have a Docker file inside my code repository. Same applies to Docker files. Building microservices, especially from the same archetype or from similar architecture, one really good and tested and trusted Docker file can really serve them all. And the only difference is maybe parameters and the package of your application itself. So it's good also to externalize these Docker files and also the deployment templates. The Helm charts, for example, or OpenShift deployment templates, it's the same idea. You can externalize these things. The last box is the application runtime configurations. And these, what I mentioned earlier, like the database connection string and credentials. So maybe for the non-sensitive information, you can come up with a convention where these configurations are managed in Git repository with certain hierarchy where you can have some sort of inheritance and extension, and a config server feeds this information to the application. And for the sensitive information, you can keep this in Vault, for example. So it's good to think about this because this will really enhance the maintainability of your overall solution. And this is a big concern if you're going microservices, because you will end up having tens and hundreds of them, and you don't want to have replication or duplication in these code bases. Any questions? So in the previous slide, it was actually the deployment engine here who is the connecting point that's aware of that. So this deployment engine can be whatever tool of your choice, Jenkins, Urban Code, GitLab, runners, or anything, Bamboo. And it's the one that checks out the code and bring all these configurations together and deploy to the environment. The good thing here is that you can achieve the point that the application itself as code repo is a platform agnostic. And this is good because if migration today is a hassle to you, you should think how to make migration easy in 3 years from now, because it will happen. Technology will change. So having your application architected and developed in a platform agnostic way is a good value, because now it's the deployment engine and the external configurations are the ones who have some awareness of the platform. So if tomorrow you want to switch from platform X to platform Y, minimal changes will happen to your application, which makes testing and releasing very easy actually at this time of migration. Okay. One last thing is strangler pattern. So imagine that here at the left, this is your original monolithic application, and the client is speaking to this directly. At the time of moving this application into microservices, you really want to have some layer of control to switch the traffic to the new microservice. So imagine that this microservice here in the middle, the first one we built, is the inventory microservice. We took this logic out of the monolithic. So you need to reroute the traffic for inventory to this one. So it's good to have some facade or layer where you can control this and go gradually to like adding microservice by microservice in a way that's transparent really to the client until you fully migrated the monolithic. So it's good to think about your architecture on having this gateway where you really can do the switching behind. It's always good to think that my first entry point is the DNS entry, then a proxy. And behind the proxy, you have whatever. You have your platform, you have Kubernetes, you have OpenShift, you have Docker, Swarm. So your applications can move from one platform to the other, and you do the switch from the proxy while you keep your clients transparent to that.
Samir, do you want to talk a bit about the time? Because this is a huge change for companies. if they're not used to this, is this something that takes years to put in place, or can you start small and see some results fairly quickly?
Mhm. What I think is the most likely scenario is not years. We're not speaking years, actually. We're speaking months. So you will not work alone. You have multiple teams will be working with you, actually. You don't take full responsibility for that. So from development point of view, I think to start have some technically robust microservices, incorporating all the nice patterns of microservices, distributed tracing, log aggregation, metrics generation, circuit breaking, bulkheading, and all these things, I think you can achieve good results within 3 months to have something that's really stable and can be promoted as an archetype. On the other hand, maybe your platform team or your infra team should think of a platform where they should operate this thing. So they may select Kubernetes or OpenShift. These things today are very famous. They have wide community support. They are easy to install. Maybe they will need some coaching to operate them in the right way, but it's not a big thing. It's something that you can have up, running, and ready within 4 to 6 months, as like you have something that's ready and fully operationalized.
And this is really the way of the future, is what we're hearing about, right? Microservices everywhere.
Yeah. The other things, you can think about them gradually, actually. Configuration management, you can think about it as, okay, this is a next phase to enhance my application. So in parallel to the development, you really do that, trying to find the configuration management approach and work with that. And the same for pipelines. You don't have to stay like blocked until you develop pipeline. You do this in parallel. You develop the simple pipeline that do the job today, and you keep enhancing it. So it's good to think about that as parallel execution. It's one big initiative, but it's parallel execution. Your development from the architecture, archetype, technology point of view, and the pipeline and the DevOps on one side, configuration management, and the runtime platform. So these are the key 4 pillars that can run in parallel to boost this time.
Is this something they can leverage if a customer is using, let's say, a SAP HANA out in the cloud that is set and can't be changed in any way? Can they use a microservice on the outside as a way to deliver some code or services that is specific to their business that might not be addressed by the whatever application they've chosen that is sort of set in stone in the cloud?
Yeah, that's fine. If I understand you correctly, this is like you have a system that's not customizable, and you want to extend its functionality. So that's a valid use case. Yeah, you really can have some microservices in front of it to extend the functionality or to make it easy to integrate with and so on. So yeah, maybe one microservice provide API in front of the system, which doesn't provide originally, and this makes the clients happy and deal with it easily, or provide better UI in front of it and so on. So yeah, you really can extend it with that. This is another good pattern to extend a legacy or non-customizable application, can be developed as microservices for sure, and hosting it on the cloud next to that or on-premise. This is really another discussion of, it involves performance, involves security and networking and so on. But it's a valid use case and it's doable. So the last thing that I'd like to mention this presentation is technology selection. Despite of our personal preferences as developers and comfort zone, it's always good to have some neutral criteria when you assess a technology or framework to be used in your modernization initiative. And these things may vary in weight depending on your enterprise. So in some enterprises, security really comes first and it has the high weight. In other smaller enterprises where innovation is like, you have door opens for that, productivity and features, they will have good weight. For critical business, reliability, scalability, and performance will have weight. So for some businesses, the openness and standards, like I need something that support the market standards for like health sector or financial sector and so on. In general, you need to think about something that has a good roadmap, so you're not going to be abandoned alone and the technology dies, and it has good community support. So whenever you have an issue, you can receive help from the community. Cost is a common factor as well. It's good to assess this because I remember one of our clients, they were trying to select technologies and frameworks and tools. And I remember the architect, they came after some workshops and webinars with their mind set on two things. One is a development framework. The other is operational visibility tool. And surprisingly, we didn't use any because for the framework that they liked so much, they liked it because it really has outstanding performance. But their use case, they needed to do some integration. And this framework doesn't have anything out of the box really to do integrations like schedule cron jobs or read FTP files and so on. And to develop these things, it's not only that you compromise the productivity of your team by reinventing the wheel, but maybe you will do some proprietary code that will, at the end, compromise the performance of the whole system. So at the end, we lean towards something that really has features more than performance, and that was more productive for the team.
Can I just stop you for a second, Andre? We have one listener that has to drop off, but he had a question, or it's more a comment, I believe. And he said that there's no one size fit all. This solution could be implemented easily if end-to-end migration is done. But if made by phases, he would say that the complexity, the dependency of microservices and troubleshooting would be a challenge. How do you balance the challenge of what you're talking about on the troubleshooting of issues as you do the migration?
Yeah, so that's why you need to plan to the minimum at the first and incorporate these things in the first wave of development. So if you are building now the first wave of microservices, like 1, 2, 3, 5, you really should come up with something that brings like log aggregation and distributed tracing and monitoring for these microservices. So you need to come up with the basic here. And the good thing is that these use cases are very common today. If I will give you, like, let's take maybe Spring Boot as an example. So it has support for distributed tracing and Prometheus metrics out of the box. And most of the Java stack, they have integration with almost all the log aggregation tools. Or you can use something like FluentD or Logstash to aggregate the logs and send it somewhere like Elasticsearch or Splunk. So the good thing is that these are repetitive patterns. So there is market-proven solutions. The thing here is to choose a solution and implement it, not really to reinvent it. And this should shorten the time.
Okay. And you did mention these type of things can be implemented in a period of months, and they start small, I imagine. So
yep.
It's not about doing a full migration, bing bang. You're going to start small with a small microservice on the outside and start getting used to how to monitor both the microservice and your monolithic application at the same time.
Yeah. So start small. So maybe log aggregation is what you are looking for. So integration with Elasticsearch, for example, it's an easy thing. And you can do it behind the scene, not in your application, but by some external components like FluentD, for example. So do it. Get your logs there. Maybe it's not the final like indexing lifecycle management you want, or the right templates, the right mapping, or security, or rollover policy. So shift this to later. Get the logs first, and then you keep enhancing the configurations on Elasticsearch. Same for monitoring and so on. So for the first run, to get the things in the right place, I think, yeah, it's doable in 1-2 months. Yeah.
Samir, we have a question from Christopher on the Q&A. He's asking, what's the minimum size of the development team required to sustain such a direction?
Okay, so the thing is, it's microservices are by definition smaller in scope than the monolithic. So if you had a team that was like 6 developers originally working on the monolithic, and now you are dividing this into microservices, so most likely 1 to 2 developers will be working on each microservice. Just this gives them good focus and like good collaboration when it comes to peer reviews as well. Because really, yeah, if it takes more than 2 developers to work in a microservice, now this thing is getting really complex, and maybe it needs to be divided.
But I imagine you work with fairly small clients as well as extremely large ones like ourselves. We have the gamut, and you must have a similar gamut.
Any other questions?
So, did you hear my question?
Sorry, can you repeat that? Maybe I didn't.
So you must work with a vast difference between clients. You must work with quite small ones all the way up to extremely large ones, right?
Yeah. Okay. So with the large ones, you have to divide things. So one very good example for these is ESB migrations. So when you look at big clients, banks, telco, government, and health, they have very big middleware implementations. So when you start building this as microservices, you can actually start splitting modules across teams. So you can have multiple teams working in parallel. And we have done this in the past. So maybe you start with one team. This one team will establish the technical, will lay the ground for the other teams. Like they will establish good archetypes, some DevOps practice, some good patterns for the operational visibility. And they will do the first 1 or 2 microservices. And now you have some reusable assets. Then you onboard another team to work in parallel on some modules of this system and reuse the same reusable artifact. And you can establish a collaboration model where if they needed to enhance the pipeline or enhance the archetype, they can work together. But it's a very good working model, really, if you want to run teams in parallel.
So thanks.
Yeah. So yeah, back to technology selection. These criteria or whatever criteria actually fits in your organization with the need, with the weights, is what you need to select technology. I told you sometimes features goes over performance. Sometimes security goes over a fancy thing. Like there is a tool that gives you lots of operational visibility out of the box, but this tool is not multi-tenant. So it's not safe to operate on a platform where you have multiple teams and departments sharing this platform. So now it's not safe. Security will have the upper say, and so on. So finally, for the next steps, we at Opticca and through R2i, we provide some discovery workshops where we can help the clients to see what they have as challenges, and then we can go build our understanding of the current state and develop with them a future state to the solution to be. And in this future state, we will address all the different areas where we see a window for improvement. Whether these improvements are some application architectural changes to be done, some configuration management issues that needs to be solved, or some automation and DevOps. And through this journey, we can also deliver some workshops to familiarize the customers with some sort of hand-ons on application modernization and microservices and DevOps and modern platforms as well. And timeline-wise, these kind of initiatives usually take 2 to 4 weeks. And now, if there's no question, I will hand the presentation back to Tamara.
Thanks. So basically, you'll assist customers in building the roadmap for how to start this journey if they haven't already started. And I guess
Yes.
you could also help them if they have started and they've got some lesson learned and might want to make some adjustments.
Exactly. So sometimes we are invited to do validation or to work on a specific area while there are other initiatives running. So that's fine as well.
Yeah, perfect. So reach out to us, and we'd love to set that up. And the 2-hour discovery workshop will really understand where is a no charge piece before we get into the building of the roadmap.
Yeah, because this is usually a discovery exercise, so it qualifies as research. Yeah.
Yeah, so we understand if there's a good fit between the companies working together.
Yeah.
Perfect. So what I'd like to talk about is some of our next webinars. As I mentioned, our summit that we traditionally do and had a lot of success with would have been yesterday, so we've moved to webinars. So we have one coming up on June 3rd. This one will be done in French, and it's to talk about asset management. So please stay tuned, and in our website, if you do R2i webinars, just on a Google search, you're going to find this link. And then we also have one June 9th and 10th. So June 9th will be in French and June 10th in English, specific to our experience with IBMI and all the services that R2i do around that. We're probably one of the largest in Canada in terms of technical support for this. And we can also one of the few that can run IBMI in our cloud, and we have several clients already doing this. So I hope you, and if that you come and attend those as well. So if you have any questions, you can raise your hand if you'd like to speak, and we'd be thrilled to have some discussions, or you can go ahead and keep asking them in the Q&A section. So I'd like to thank everybody for their time and for attending the webinar, and we'd be interested in your feedback. So that's the conclusion. Are there any questions, or anyone would like to raise their hand to ask a question, and Kim will unmute you or continue to ask in the Q&A. So I don't think we have any questions, right, Kim?
No question for the moment.
So please feel free to reach out to us, and we can set up as the next step a discussion with Opticca to see if there's a good fit in assisting in building out a roadmap. So thank you, everyone, and thank you very much, Samir, for your time. And we finished in time.
Thank you.
Very informative.
Okay. Thanks.
Thank you, everyone.